Okay, so here's just a quick presentation on how to graph the data for Ohm's law. So you're going to have 6 columns in your worksheet. You're going to put in the current and the voltage that you measured in columns A and B, and I've just put in some fake data there, 1, 2, 3, 4, 5, etc. And then in column C, you're going to put in the uncertainty in the current. I don't know what it will be. Let me just make up a number. Let me say it's plus or minus 0.1. You'll get that off your multimeter. If they're all the same, what you can do in Excel is if you click on the cell to highlight it and then move your cursor, you can see now I have a white plus sign. Move your cursor to the bottom right corner. It turns into a black plus sign. Drag it down and it will copy it down. And let me make up a number for delta V. And I'll put that on. Okay, so if you want to, you could calculate R is equal to voltage divided by current for each one. But I'm going to get Excel to do the work for me. So my equation is R equals V over I. So in this cell, E2, I'm going to type in equals, and it's going to be this value, 2 divided by 1. Right, so I'm going to say B2, and you see it grabbed, highlighted that cell in blue, and also put the writing in blue, divided by this current, which is in cell A2. Okay, so now it calculated my R, which is 2 for my imaginary numbers. I just made everything, the voltage twice the current. And then if I go down to the next one, I want to put in B3 divided by A3, B4 divided by A4, but rather than type it, Excel will copy it for us. So if I click on the cell with the formula in it, and if you look, I see a number 2, but if you look up in the formula bar up here, you see that it says equals B2 over A2, and if I click on it, you can see again it highlights the cells in the correct colors. Okay, so I want to grab that column E2, and I'm going to hover over that bottom right corner till I get the black plus sign, and then I'm going to drag down, and it's going to copy the equation. So you see if I go down in the bottom cell here, it did B9 divided by A9. You don't see any variation here, of course, because my numbers are imaginary. All right, how about delta R? Well, for delta R, I'm going to get Excel to do the calculation too. What's the equation? Well, the equation is shown over here at the right. Delta R, because I'm doing V divided by I, I'm going to use the division equation. So I'm going to do the uncertainty in V over V squared plus the uncertainty in I over I squared times R. So what will my equation be? Well, for each value in this column, I'm going to have to do it differently because the V and the I are different, so the numbers under the square root will be different. And for you guys, you're going to have a different value of R2. Mine are all exactly 2 just because I faked the numbers. So what am I going to put for an equation? So for F2, I want to put R outside the square root. My R value is E2, so it's going to be equals, you always have to start with equals to let Excel know you're going to do a calculation, equals E2 times, so you do asterisk symbol, the square root, SQRT, of, now open brackets, so that's starting my square root sign. Then I'm going to have delta V over V squared, so I'm going to do open bracket. Delta V, for this one, is I'm all in my row 2, so delta V is going to be D2 divided by V, which is B2. So I'm going to do D2 over B2 and square it. And then I'm going to have delta I over I. Delta I is C2 and I is A2. Squared. All right, so I've got delta V over V squared, delta I over I squared. So now I'm going to close my bracket for my square root, and that should be the equation that will give me my delta R. So let's try that and see if it gives me an error message. So equals, start with the equal sign, E2 times, E2 times the square root SQRT of, another bracket, D2 over B2. To do a squared, you do the caret symbols, 2 plus open bracket C2 divided by A2 squared, and then finally close my square root sign. All right, so I've got everything is highlighted in different colors. You can double check to make sure it's right. Hit enter, and that gives me that my uncertainty in R is 0.538. And now I can again pull that equation down. I don't have to keep typing it in, and we'll do the calculation. So you can see that for small values of I and V, because the uncertainty is large relative to the current and voltage, I have a much bigger uncertainty in the resistance than I do for the larger values. Okay, so how are we going to get the resistance? Well, there's two ways we're going to do it. One is we're going to do a standard deviation, so an average mean and standard deviation for column E. And the other way we're going to do it is to do a graph of current on the x-axis, voltage on the y-axis. We need to put in our error bars, and we need to put in a best fit line. So to do the graph, I'm going to do current and voltage, select those two columns, and then we're going to go to the Insert tab at the top. I'm going to insert a chart, and I need to put in a scatter chart. So if you pull down, it's this one here with all the dots. You don't want to do the lines. You don't want to do it to connect the dots. You want to do just the dots. So we're going to put that in. And when you do it, always double check and see, is your current axis going from 0 to about 8? Yes, your data is going from 0 to 8. How about for the voltage axis? Looks like I've got my first point at 2, my second point at 16. So that's doing it right. Okay, so what do we need on a graph? We need axes labeled with units. We need a title. The title cannot be current versus voltage. You need to make up a title that makes sense. So I'm going to not give you a hint. I'll just say this is a good title. So make up a title that tells the person what you're doing in the experiment, not that it's current versus voltage, because they'll be able to tell that from just looking at the X and Y axis labels. All right, so how do I put on my X and Y axis titles? There's two ways. So depending on which version of Excel you have, if you click on the chart, you can see I have a plus sign here, and I can add axis titles, and you can see it pop them in there. Or I can go up in the chart tools. Under design, you can see add chart element, and I can tell it to put in my axis titles and chart title if it wasn't there, all the different kinds of things that we can put in. All right, so let's put this in. So my horizontal axis is my current. I need to put in my units. Vertical axis is voltage. And that's in volts. Okay, what else did I say we need? We needed a best fit line, and we need error bars. So how do I put on error bars? Well, two things I can do. One is, again, click over here and put on error bars. And you see when I tick error bars, it just pops up standard vertical and horizontal error bars. So if I see a graph that looks like this, I know it's bogus. You didn't actually use your real error bar values. We have to go and put in that the horizontal error bar should be 0.1 long and the vertical error bar should be 0.5 long. So let's go in and do that. So let's go into the error bars. We'll click this side button and we'll say more options. All right, so right now we're formatting the horizontal bars. See, it says horizontal error bars. I want to go in both directions, up and down, sorry, to left and the right. I'll put a cap on the end of it, just makes it look pretty. And then what do I want to do? Well, I want to tell it what the value is. So I could put fixed value. So if all your error bars are the same length, if you use the same scale on your meter all the time, then you could just put in a fixed value. If they're not, then you need to go down to custom, click on the specify value, and then for positive, I want to do just select the cells that have the errors in it. So I'm going to select from C2 to C9 and do the same thing in the negative direction. Again, make sure that you delete out what it has in the box beforehand. Again, depending on the version of Excel, sometimes it does an error. So now you can see those horizontal error bars shrunk way down, right? All right, now I'm going to click on the vertical error bars. So just click till I got them selected. And now you can see, again, I've got the format error bars box at the side. And I'm going to make them, let's see, I got to click on this 3 bars symbol to get the right thing. It says standard error. I don't want standard error. So I'm going to do custom, specify value, delete what's in the box, grab my delta V's. And same thing for negative, delete what's in the box. Scroll down from D2 to D9. Hopefully I'm grabbing it right. It's behind my graph so I can't see it. All right, so those shrunk down too. If your error bars are so small that you can't see them, then you need to write on the graph that the horizontal error bars are smaller than the point size, or the vertical error bars are smaller than the point size, and that will allow you to tell the person that you put the error bars on. Otherwise, if I'm grading it and I don't see error bars, I'll take off points, thinking that you forgot to put them on. All right, so last thing we have to do is do a trend line, fit to the graph, fit to the curve, and get the slope, which will tell me my resistance. And I also need to get an uncertainty in the resistance. All right, so how do I do that? Well, again, I can click on the graph and do plus and trend line, or I can go up to the chart tools, design. Let me do that just to be different. So I'm going to add the chart element, trend line, and I'm going to say more options. And I want to do that because although I want a linear line, I want to display the equation on the chart. So down at the bottom, hit display equation on the chart and hit display R squared value on the chart. So you see it popped some equations on there. I'm going to grab those equations and I'm going to pull them away from the line. Okay, so now it tells me that my equation of the line is y equals 2x. So that means that my value for the resistance is 2, right? Because y equals mx plus b. I don't have an intercept here because I put in perfect numbers. You guys will get an intercept value. My r squared value, r squared of 1 is a perfect fit. You should get something in the 0.9s if your data is good. All right, so we're almost done. We need an uncertainty in the slope. Now, if you were drawing this with pen and pencil, you would take another straight line, you'd put it on. That's the worst fit straight line. So usually I'd go from like the top error bars to the bottom error bars, get the slope, and that would give me the uncertainty in the slope. In Excel, you can use an equation to calculate it for you. So what I'm going to do is I'm going to move this graph over a little bit. I'm going to grab an area that's 2 cells by 3 cells. So you can click and drag, or you can hold down shift and just move your left arrow, right arrows. And now without clicking anywhere else, I'm going to go up into that formula bar at the top where it says fx. And I'm going to type in an equation that will fit the line. So it's LINEST. Oops, hang on. I just realized I made it the wrong shape. I need to make it, I believe, 2 by 3. So 2 across, 3 down. All right, let's try that again. Equals LINEST, open brackets. And now you see down here it says it wants to know what are your Y values. So you're going to click the Y values, your voltage. So you're just going to click and drag there. Then hit a comma, then it says what are your X values. So I'm going to select column A. Then it says constant. That means do you want to set the intercept to 0? No, we don't. So we're going to calculate it. So we're going to put 1. And the next thing is, do you want to know what the uncertainty is? And the answer is yes, I do. So I'm going to put 1. Close the bracket. Now this is a very important part. Hit Control Shift Enter. Don't just hit Enter. Hit Control Shift Enter. Or if you're on a Mac, Command Shift Enter. And you see it filled in that array. So for the array, the first value is the resistance. The one below it is the uncertainty in the resistance. The second one is the intercept. And the next one is the uncertainty in the intercept. So this is the value. And this is the uncertainty. Now, of course, because my intercept was 0, because I fudged my numbers, you just get this really small number. For you guys, you'll get something that looks reasonable, and you can compare to your graph. So I've got 2 is my slope, and that tells me that's my slope. So this is my R, and this is my intercept. All right, so my slope is 2 plus or minus 1.7 times 10 to the minus 16. Let me fudge some of my numbers so I get something a bit different. So let me do, I don't know, let me make this 4.5. I'll make this one 9.5. So now my resistances and delta R's have changed. If you look here, you can see now I've got some scatter in it. And now my slope and my intercept change, and you can see that this table over here updated. So my intercept is 1.96 plus or minus 0.04. So my R is equal to 1.96 plus or minus 0.04. And so that would be the value that I would put on the worksheet as the slope plus the uncertainty in the slope from the graph. Okay, so hopefully that makes sense, and you can follow it in your version of Excel. If you have questions, send me an email. Don't wait until 11 o'clock on the night it's due.